Hi all, thanks very much. I'll be talking today about, as Peter said, a bit of my dissertation research, which looks at the introduction of copyright in the 18th century and copyright's influence on the book market writ large. And today I'll be looking at patterns in derivative artistic practices, so text reuse, image reuse, and how those sort of patterns were massaged by changes in copyright law during the period. So this is computational research in the humanities that sort of builds on a lot of prior computational research in the humanities. The earliest example of which I could find is work by Patricia Margaret Took, who has this beautiful hand-drawn distribution of the number of printers and the number of books published in the early modern period. So this is back in the 70s. This is in her dissertation, pioneering work for computational studies of the early book market. Later work by folks like John Feather were analyzing distribution over topics within books published in this period. Subsequent work by Elaine Velit, starting to compute some of the sort of basic descriptive statistics of books published, let's say before 1800 in the early modern period. And then more recent work by folks like Michael Suarez, who again, here he's looking at distribution of book lengths over history. But there's been very little analysis of the ways in which copyright law may have influenced the book market. In fact, there's been very little quantitative work done generally in the humanities. Humanities papers tend to be presented in tweed jackets and read from a sheet of paper. There's very little computing going on. So to set the stage for what we'll discuss, I'm just going to sort of walk through the relevant historical moments very briefly. Copyright's invented in 1710, statutory copyright anyway, which is sort of written law copyright. Before that, it's all royal proclamations. And so after 1710, there are a number of cases that are fought over sort of derivative works where an author is abridging, plagiarizing, adapting an earlier and extant work. And the plaintiff wins in all of these cases. The defendant is unable to defend a derivative publication. Fast forward to 1741, and there's a very prominent case, Giles v. Wilcox, which is fought over a publication by Fletcher Giles that we just saw. So John Wilcox had basically abridged Giles's text and published it, and Giles was understandably upset. He took Wilcox to court, and Wilcox defended his publication on the basis that he had highly manipulated his source text. He had transformed it in a number of ways. He wasn't going to influence the marketability of the original text, et cetera, et cetera. And so his derivative publication was identified as a distinct copyrightable work and was found non-infringing. And so this precedent in 1741 opens up the opportunity for a number of subsequent cases, all of which have derivative artistic text reuse that are defensible, that are found non-infringing. So this is a really sort of watershed moment in history. I mean, this is the creation of fair use copyright law in 1741, at least for texts. In the image domain, there was no fair use law until a very sort of breakthrough 1785 case, Sayer v. Moore, and these are the actual images that were disputed in that case. On the left, an image of the sort of eastern seacoast by Robert Sayer, and on the right, if you look at just the left half of this image, the same by John Hamilton Moore. And if you kind of squint at it, you can see the coloration is very different, obviously, but the figuration is highly similar. And in fact, Moore's maps were based on Sayer's. And this was proven in the case. In the case, it's discovered that certain misidentified labels in the Sayer map were actually also transcribed into the Moore map. And that becomes like an artistic trick. Artists would deliberately encode false information into their pictorial graphs so that if they were sort of reprinted, they could identify those telltale marks. Kind of clever. But in any event, because this was a C chart and because Moore's map, the derivative map, made a number of improvements on the plaintiff's map, his map was actually found non-infringing. It was found to be a defensible work. And so this creates precedent for a number of subsequent cases, all of which revolve around derivative image production, where a derivative image is found to be non-infringing. And so the research question that this part of my work sort of addresses is, does the rise of fair use precedent incentivize, increase rates of derivative artistic practice? So once you get a precedent for text reuse that says you can infringe on other people's works and your work will be defensible, it'll be monetizable, do we see rises in sort of frequency of text and image reuse? And a number of prominent scholars have sort of contributed to this debate. Essentially, Ronan Deasley, professor of law, has said essentially yes. And William St. Clair, who's one of the few who's tried to actually grab some numbers to analyze this question, he said no, he doesn't think so. But St. Clair is operating on the order of just about a dozen cases that he's kind of analyzing. So what I want to do is to address this question sort of at the level of collections. And the data for this comes from actually two distinct repositories. There's a great collection of 18th century books called 18th Century Collections Online. Those are the red dots down here. And we can measure sort of the degree to which that sample represents the full corpus size, the full population, by comparing the ECHO publication stats to the English short title catalog. The latter, the ESTC, is a bibliography of all texts known to have been published in English from 1472, the introduction of printing, to 1800. So it's an absolute sort of historical backbone against which we can measure representativeness of a corpus, which is very rare. In more modern times, we have no idea the full print run of a given historical sweep. It's just too much. But we can see here that ECHO's sort of highly correlated. ECHO publication rates are highly correlated with the ESTC, so this is a highly representative corpus sample. So here's a sample page image from ECHO. This is a page image, a page scan that has an image, obviously, it's text. This is a sample ballad, a little poem form. And so this is one of roughly 35 million page scans in all of the ECHO corpus, all of which will be analyzed in the work that follows. And there are a number of problems with this data, one of which is that we can measure representativeness of the ECHO corpus versus the English short title catalog, but we don't know what's missing from the English short title catalog. We don't know the survival rates of books. A lot of books have kind of just disappeared from history. And there's actually very little work on measuring like probability that a given work would have disappeared, or that's measuring survival rates of books. And so if we look at the records in the English short title catalog, which are gathered from over 2,200 libraries worldwide, we can look at the sort of percent of books over time that are held in just a single library that were basically on the verge of becoming extinct. And you can see it's up to 60% in the very early period. Things kind of dip down. So a significant portion of sort of book history is just absolutely missing and can't be part of the study. But we've got decent numbers that have survived. Geographically, there are problems too. The vast majority of publishing is happening in London. That's this sort of bleeding heart down here. Whereas later in the century, or later in the period, you get a lot of publishing in Edinburgh and in Dublin, which are kind of hotbeds of reprinting because they weren't subject to English copyright law provisions. So printers in Edinburgh and in Dublin can reprint wholesale. They can sell records in London. They deliberately misidentify title pages. They lie and say that a record was published in London because London publications were sort of hotter commodities. And then there are kind of intricacies within these different geographic locations. So for instance, if we look at optical character recognition quality over the 18th century in these different cities, we can see that London had nicer type. It tended to be preserved a bit better on the page, and so the OCR rates are higher. Whereas a lot of Dublin printers are working with like second-hand presses. They have old typeface. and the sort of character, the imprint quality, the actual ink pressed onto the page is much lower. So although Edinburgh and Dublin are kind of, again, these hotbeds of reprinting, we can't capture as much from them because the signal is less strong. So a lot of problems with the actual data. That said, we'll begin by looking at patterns in derivative text reuse. And as we've observed, this is all optical character recognition data. So these are page scans from which we've inferred a character sequence. And OCR rates are variable over the period. You can see that sort of mean line there, drawn roughly in the 80% region. So this is to say that the text reuse algorithm needs to be sufficiently fuzzy in order to work with these character irregularities. We can't count on perfect sort of word-level transcription rates. And so the technique used for this part of the study is called the min-hash algorithm, which allows us to analyze text sequences and identify these hashes, these sort of derive these characteristics of the text, such that we can compare the characteristics of two passages and identify what, with a certain probability, whether or not they match. And so the basic notion here is we're going to take each of those 35 million page scans, we're going to break it into a sequence of multi-word windows. For each of those multi-word windows, we're going to break that into a number of character sequences, 3 character sequences. So REP, first 3 letters, EPO, POR, so we have a subsequent sliding window of going over characters. We're going to quantify each of these character sequences, and then we're going to take this sort of quantified representation of the character sequence, and we're going to use that to update a global vector for this window. But this vector is just a list of n numbers. An n is a parameter of the min-hash algorithm. So this might be 128, let's say, values, and we're going to use this value modulo 128 hash functions, which is just to say, like, kind of clock time, but if we hit 12, we're going to go back to 1. So we're going to be flipping these numbers by virtue of this number, just like a clock, essentially. Each of these is going to update this local vector, and at the end of the day, we're going to pass a sliding window over this vector, and we're going to take each of those sequences and add this record to the list of records in which that sequence of values occurs in the vector for the window. So this lets us analyze text reuse in linear time, which is much better than comparing 35 million page images to 35 million page images. That's nice to have that optimization. And so with this sort of min-hash technique, we can identify fuzzy text reuse, such as the passages here. We have a recipe. It's interesting to look at the kinds of things that are plagiarized. Recipe books, song books are often plagiarized. Legal books, often plagiarized. It's highly ironic. And so we'll get a chance to see some of the actual OCR underlying some of this in a second. But this is the kind of fuzzy text reuse we're trying to identify. Then, of course, the vast majority of the kind of aligned passages, the identified instances of text reuse, are solely a function of edition reprints. So we have 3 different editions of Robinson Crusoe. They're 120-something odd. And in fact, if we look at reprints over the course of the century, like almost half of publishing that was happening during the period were just reprints of a given successful volume. So we have to use elaborate measures to sort of construct this big graph and connect each of the edition reprints with connected components that allow us to identify that this region is all Robinson Crusoe, whereas this is an actual plagiarism of Crusoe. So if we flush all of this out, we remove those just edition reprints, and we analyze the actual rates of derivative publication over the period. We get these pretty smooth curves. We can see that sort of reprinting behavior grows throughout the century, but then kind of reaches a saturation point. It's like almost a market saturation, and then there's no subsequent growth. But we don't see a big spike after 1741, after Giles v. Wilcox, which we would expect to see had Giles v. Wilcox influenced derivative text publication. So, so far it looks like the rise of fair use in the text domain has not influenced text reprinting practices. What about images? Well, here's just the sort of image corpus, how many images are being printed over time, several thousand annually, and these are the different image types. Okay. In this sort of processing pipeline, there are a number of challenges posed, one of which is the sort of variance within exposure rates. So these are two different images, two different page scans of the same edition. And you can see on the left, obviously, we have far less signal than the one on the right. There are these strange eccentricities of the corpus as well, where sometimes two pages will be kind of consolidated into a single page image. So these are distinct pages. This right side page is one composite image that somehow represents the two images. It's almost like an automatic page flipper got stuck. I'm not sure. Other strange sort of figures where it looks like someone's gone in with scissors, and they particularly like this woman, and so they just cut her out, pasted on some 18th century wall somewhere. So this is, a sort of reprinting of the image, but there's very little signal there to capture that with. And then there's the more sort of philosophical problem, which is that you can have two images which are highly similar, and then it becomes almost a probability game. What is the probability of simultaneous co-discovery of these two images? What's the probability that these two images were generated independently of each other? Just by virtue of the fact that this is a large space, and there will be random occurrences where two authors will, or two engravers will generate the same image. And so even deciding in a number of cases whether or not two images are derivative can be difficult, I think, for humans. So when we run this image computation, and I'll say really briefly that this is, I had the most Baroque labyrinthine pipeline for this. This involved using sort of vectorized image representations from inception, key point-based image analysis techniques like SIFT and SURF, image hashing techniques like a perceptual hash, an average hash, combining all of those features together and then actually just using an old school support vector machine classifier given that feature. And that was trained on 300,000 observations, image pairs that were binary classified as matching or not matching. I'm happy to share that training data. That was very painful to collect with the jankiest web app you've ever seen. That using that data, we can sort of analyze all these images, and we can do a number of things. In the first place, we can identify kind of editorial practices. So these are three different page samples from the champions of Christendom. And you can see that the author's kind of changed his mind about the skeleton. He didn't quite like this skeleton, and so he's upgraded his skeleton in each of the editions. Kind of interesting. But we can also identify a number of very subtle plagiarisms, where an engraver was actually referring to a source image and sort of recrafting it. And so I spent weeks analyzing these kinds of image pairs and trying to spot the difference, trying to determine exactly where the subtleties are. But if you look at, let's say, this is the people, there are two people sort of sitting here, and they're slightly different. If you move over here, this was a kind of regular occurrence where an author, an engraver, would hire someone else to sort of recraft, reimagine an image. So this is a perfectly derivative image published by a different author, a different publisher than the original source image. And we can identify these at scale. On the left, this is an image by Thomas Jeffries. And on the right, this is actually a publication by Edmund Burke. And you can see it's kind of flushed out the Jeffries image. It's ironic because Jeffries was the defendant in a number of image dispute cases where he was actually plagiarizing others. So there may be a sort of history here where Jeffries is plagiarizing and Burke is plagiarizing on top. But if we look at the rates of image reuse over the full sweep of the century, we can see it's very minimal in the first place. In fact, only about half of 1% of book publications contained derivative images, contained plagiaristic images over the sweep of the century. And there's no noticeable spike after the Sayre v. Moore case in 1785. So To return to the original question, does the rise of fair use precedent increase derivative artistic practices? It seems William St. Clair was right to think not. Thanks very much.